guys, back again. Okay, so this time we're going to be talking about price elasticity, where the demand is going to be okay. Price. I'm going to make this bigger for you guys. Better? Okay. Price elasticity where put this down actually, where the demand equals -1.5 and the price of product equals 10%. So what happens to the quality demanded? We're gonna what happens to quality demanded? That's the main question, right? Okay, we're gonna put this down so you guys can see more. Yes, great. That's just the basic things you guys can get from that. Okay, so to answer that, you're gonna use the formula change in quantity demanded, usually just QD in most of your classes will be it, times elasticity times change in price, which is going to be 10%. Yes. And what does that equal? So the elasticity here is 1.5, already set in the product, and problem where the price elasticity of demand is -1.5, times the change in quantity demanded, which is a 10%, and that's just going to equal a basic like -15%, and that's going to be the quantity demanded. So to say this is going to be the quantity demanded decreases by 15%. Yes. Okay. Next, we're going to go to the different question. I'm just going to leave that there for anybody who needs it. Cool. Next question. We're going to calculate the total revenue of if a firm sells 100 units of a good at $50 each. So total revenue, question mark. Firm sells 100 units at $50 each. So the equation is going to be total revenue equals price times quantity total, price times quantity, which can be said total revenue equals P times Q. And here, that is going to be 50 times 100 equals 5,000. These are really basic formulas. This can be like shown anywhere on your test and like quizzes though, but these are things that people need to know from the basic economics. Okay, the harder we're gonna go into harder parts, but does anybody have any questions? No? Okay, cool. We're going to go on to calculate equilibrium price and quantity if the supply equation is quantity supplied, which is going to be QS. Let me write this down for you guys first. Oopsie daisy. Let me see, you guys can see this right here. We're going to like just do that right there. Cool. Okay, so don't do like a line here and a line here. And make sure that's visible for you guys? And let me know if you guys have problems seeing. Okay, so what is the equilibrium price and quantity? We're going to look at that. Equilibrium price, question mark, and quantity, question mark. Okay, so the equation for here is the supply equation specifically, because you can have a difference between the supply equation and the demand equation. Supply equation, we're going to erase that. Okay, supply equation is going to be quantity supplied equals 2P. P is going to be denoted as price. 2P minus 4Q quantity supplied. And this can be simplified as saying 2P minus 4. And the demand equation is going to be quantity demanded equals 20 minus P quantity demanded equals 20 minus PQD equals 20 minus P. Cool. Okay, so at equilibrium, we have to, we already know that Q, the quantity supplied equals the quantity demanded. 2P minus 4 equals 20 minus P. Now I have to solve for P. Right, let me write that down for you guys. QS equals QD, which is just 2P minus 4 equals 20 minus P. Solve for P. Can you guys see that? Yes. Solve for P. Let me make it like a little bit colorful. That's the whole thing we're gonna do, right? Cool. Okay, let's make it a little bit smaller and that you guys can see everything I'm doing. Cool, great. We're going to move on to the next step. And next, after you write down what quantity supplied equals quantity demanded, you're going to substitute P. Substitute P for 8. Today is it? So here, solving for P would be 3P equals 24. And you can get that from making putting them all to the same side. Yeah. Because, and how I did that, okay, yeah, how I did that was adding 4 over here, and that's going to be 2P equals 24 minus P, and then I did plus P on the other side, so that goes over here, and that's how we got that. So it's going to be 3P equals 24. Just divide 3 from both sides, and you get P equals 8, and that is the price that we're going to be using for the entire thing. And next, we're going to have to find out what the quantity supplied and the quantity demanded are. So now that you already know the quantity supplied, which is basically also the equilibrium price. Oh, P is the equilibrium price, by the way. And we just substitute that into one of the equations. So we can substitute into the quantity demanded equation. So let's put this as a blue, because I like blue. So the quantity demanded was 20 minus PQD, and we're just going to replace that over here. So the quantity is going to be 12. Now that we know what P is and we know what Q is, we can solve for quantity supplied and quantity demanded. I'm just going to go over here and create space for you guys to see. I'm going to delete that. Yes. Okay. We're going to move on to this part. Oopsie. Okay. So next we're going to solve for the quantity demanded and quantity supplied. We're going to put this over here and say that quantity supplied equals quantity demanded And that's going to be 2p minus 4 equals 20 minus p. And we're going to get that 2p, that minus 2p minus 4 equals to 20. We're going to, we're going to substitute those questions. We're going to substitute those formulas that we already put in, right? So it's going to be 3p equals 24. 8 8, we already know that for sure. P equals 8, and we're going to put it all in where quantity equals 20 minus 8 equals 12. Put that into there, and you get that the quantity supplied is going to be 2p minus 4qs, which is going to be 16 minus 48. I'm going to get a negative number for that. So for this one over here, quantity supplied is going to be 2p. 16 minus 4 times 12, 48. And that's going to be like, I'm thinking negative 22, negative 32. Negative 32 for quantity supply. And for quantity demanded, just going to plug that in. We're going to get 20 minus PQ, and you already got that as 12. Great. Next question. We're going to solve for GDP. So for GDP, let's make that a little bit smaller, and let's put that all over here. And then just like zoom in a little to right here. Okay, cool. We're gonna put this over here and squiggle, squiggle, squiggle. Cool. We're going to solve for GDP. So GDP is defined as consumption plus investments plus government spending plus exports minus imports. And you just like plug in numbers. Whenever a question asks for that, a lot of the times when I took tests in college and they asked for GDP, they phrase it kind of weirdly. So when they say like, oh, exports minus imports, sometimes they're just going to show you the exports and think like there's no exports and imports available. And for consumption, it really depends on if the country is big or if the country is usually known for their imports and exports. So we're going to solve for nominal GDP specifically because there's a difference in their GDPs. And right here. GDP is consumption plus investment plus government spending plus exports minus imports. And for clarification, so you guys can know what they stand for. Oh, that's really faint. I don't like that. Let's go for purple. Yes. Okay. Consumption. That's investment. Government spending. Exports. And imports. Cute. Okay. Next, we're going to look for nominal GDP. So let's say a country produces 2 goods. Country, 2 goods. They produce 10 units apples. $2 each is the price per apple, right? Yes. Okay. And 5 units of bananas. 5 units. And they're priced at $3 each. Price per banana. Okay, I'm gonna move this down for you guys a little bit so you can see everything I'm doing. Cool. And with that, you can find nominal GDP by doing this like simple formula where it's going to be, let me change the color for it so it's like easier to see. Okay. Nominal, I think it's like boop, 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 so you can see a little bit better. Okay. Nominal GDP is defined as the quantity apples, parentheses, times the price of, let's just say apples right there, right? And plus the quantity of bananas times the price of bananas. Super simple equation, right? Okay, and that's times, and that's going to be make your nominal GDP. So as we already know, the quantity of apples is 10 units. So it's going to be, it's going to be 10 units times the price, which is 2, plus 5 units. 5 units of bananas times the price of bananas, which is $3 per unit of bananas. And that's going to give you 20 plus 15 equaling 35. And that's going to be your solution for this is going to be your solution where that's the nominal GDP. Cool. Okay. Next, we are going to go on to cost analysis. Okay. So this is all the work we've done so far. I know there's a lot, but let me know if you guys have any questions and I can answer them as we go along. We're going to use this space right here where it has been untouched and make another problem based on the cost analysis. Oopsie daisy. It's going to use a space, and we're going to be doing cost analysis. Let's zoom in a little bit so you guys can see. Perfect. Okay, cost analysis. Cool. So in this question, a firm's fixed costs are $1,000. So let's go write that first down. Firm's fixed cost is $1,000. Okay. And its variable costs are $500 when producing 100 units. Variable cost when producing units is going to be 100. Cool. Okay. What is the total cost and average cost per unit? We can solve that by using the basic formula. Total cost equals fixed cost plus variables. So we already know what the fixed cost is, and we already know what the variable cost is. So it's going to be total cost equals fixed cost. Let me just make sure that's smaller. Cool. Cost. Ooh. Make that more legible. Cost plus variable cost. And that's going to equal 1,000, plus 500, giving the total cost of 1,500. And next, you're going to use that to make the average cost and find that value. A lot of part of economics is like a lot of steps. And I don't know about you guys, but like we didn't have cheat sheets most of my college experience. So this has to be like memorized very fast, very, very fast. So next we're going to do average cost. Average cost equals total cost and divided by quantity of units, right? So we already know that a total cost, we found that from here. Oops, no, we didn't. Not that. We didn't find that from that. We found that from right over here. Yes, ma'am. So we found that, and it's going to be 1,500 divided by 100, and we got that from here. So it's going to be that total is going to be just $15 per unit, and that's how you find the average cost. 15, boop, boop, right there. Basic math. And that is going to be the average cost per unit. And that's just like a basic cost analysis problem too. Okay, cool. Next, what happens to marginal cost as production increases, assuming diminishing returns to scale? Very like basic concept questions. And in this scenario, marginal cost increases because each additional unit of production requires more resources, leading to inefficiency. Okay, cool. Next, we're going to do economic indicators, specifically working with inflation. I'm going to use this space like right over here. Oop, I took up a lot of space for that. Oh my gosh. Right here. We're going to just use this space. Yes, cool. Okay. Okay, lovely. So we're going to do economic indicators. And we're going to be working with inflation rates and specifically the consumer price index. So first, title this part, economic indicators. Let me like increase this so you guys can see. Cool, okay. So the question is, if the consumer price index was $120, 120 last year and 125 this year, what is the inflation rate? So we're gonna do consumer price index. Also know the CPI, usually like mentioned in economic reporting or like Wall Street Journal, if you guys are into that, was 120 in year 0 and 125 in year 1. What is the inflation rate? What is the inflation rate? Okay, so after that, we're going to use the inflation rate formula, which is pretty much a simple formula where inflation rate equals the new CPI minus old CPI divided by old CPI. Oh, let's move this over here. Times 100. Okay. So in this equation, it's going to be, I'm just going to say IR, and that's going to equal, let's erase this. That's a parentheses. It's going to equal 125 minus 120 divided by 120. Again, because that's the old one. No, that's the old one for year 0. times 100. And that whole equation is going to all equal to 4.117. And that is the inflation rate that happened from last year to this year. So like, let's say all prices went up by 4.17. That's not usually the case because there's a lot of prices, but still, let's say like that happened, right? Okay. All right. We're going to go over next comparative advantage. Any questions so far? No? Okay. Let's see, comparative advantage. Here's all the problems we've done so far. We've covered equilibrium, cost analysis, nominal GDP, price elasticity, and the common indicators of economics. We're gonna move over here. Actually, we're gonna like move over here because we haven't like tackled that space yet. Cool. Okay. Make a little squiggly here to box it off. And we're going to focus on comparative advantage. Ooh, that's really small. Let's make this bigger for you guys. Cool. Okay. Comparative advantage. A little underline. Great. Okay, so the question for this one is, if country A can produce 10 cars or 5 computers and country B can produce 8 cars or 8 computers, who has a comparative advantage in computers? So let's write this first all down. First, we're going to do country A. Country A has 10 cars, 5 computers, and country B can produce 8 cars and write that better. 8 cars and 8 computers. I'm gonna write comp because you guys know what I mean. So who has comparative advantage? Who has comparative advantage? Okay, so I could first, okay, comparative advantage, you have to find the opportunity cost first, because sometimes it's easy to look at it here, like, oh, comparative advantage in computers specifically. That's a good thing to note, because it can really change depending on what you're trying to find comparative advantage in. So in country A, you can already tell that they have comparative advantage because it's easier for them to, it's 2 computers, 2 cars here would mean 1 computer for them. But in country B, it's equal. Like if they give up 1 car, then they're immediately giving up 1 computer. But there's a mathematical way to actually solve for that. So first, we're going to look at the opportunity cost. So the opportunity cost for country A is 10 divided by 5. 10 being the amount of cars, 5 being the computers. So 2 cars per computer compared to country B. And we're just going to label this country A so we don't forget. Country A. Good. And the opportunity cost for country B is 8 divided by 8, which is the 8 cars divided by 8 computers. So you can see how many cars that they lose by 1 computer. Or like how many cars it takes the production opportunity cost for 1 computer. So it's going to be 1 car per computer. And as you can see, they have the one with the highest opportunity cost, aka that's going to be country A. because they have higher. And it's because the reason it's the higher one that has a comparative advantage is because the country that loses less when the country that values something more has a comparative advantage because they lose less, if that makes sense. Let me know if that makes sense. And okay. Those are all like the equations I have. Does anybody have any questions? Like anything they want to go over, like any problem they've been having with economics recently, or they've been wanting to go over? If not, let me know. If you do, let me know. This is all like we've gone through right now. I know it's like quite a bit, but it's super helpful to go through different questions all the time and to make sure like to check out things like Chegg to make sure that you're rehearsing different questions and like different ways that they ask questions on exams. Okay, cool. So I also have like a list of formulas that I think you guys should know throughout your entire like economics journey. I know in like my master's courses, sometimes we don't really use them. And if you want to go into advanced education, they usually rehearse or like rehash a lot of equations that you learn in undergrad, but in a very much advanced way. Like you're not going to be told, you're not going to be asked, okay, what's cost analysis again? You're going to be made to use it immediately after they describe it one time. Okay, cool. So I have like about 15 formulas that we can go over. First, supply and demand. The basics. Always going to the basics. We're going to use the space over here. Boop. Okay. Cool. Gonna knock off this part where we're going to label formulas. Okay, cool. That's really light. No to that. And new to this. Okay. Formulas. Because economics is so math-based, very important to know your formulas, very important to know your equations and how to use them, and especially when to implement them, which I will be showing you guys after every single formula I do. But the first formula we're going to do is we're going to do a supply and demand. And specifically, there's 3 different formulas in supply and demand. There is the elasticity of demand or supply, which we touched on previously in the tutoring session, and cross-price elasticity, and also income elasticity. Cool. Okay, so write as supply and demand. Let me make this bigger for you guys so like you guys